All right, so this is the assignment for lesson 9-2. This is really where calculus and trigonometry, where they finally meet up. And see these derivative rules, these formulas? There's no way around it. You're going to have to memorize them and know how to use them. There's no shortcut to that. So each derivative rule you need to know, and the best way to remember a rule is by practicing it. But if those that like flashcards and to be able to practice it, the work you put into remembering the formulas will pay off. All right, so here's the assignment. And we're just going to go one at a time. They're not going to be very long questions. So y equals 3 times cosine t subtract 2. What's the derivative there? So I need to know the rule for cosine. And so the rule for cosine is negative sine. So it's negative 3 sine t subtract 2. And then the derivative of t, well, what's inside is 1, so there's no hook on at the end. So the rule for cosine is negative sine, and there it is. Number 2, off and running. In number 2, it's f of x equals x subtract sine 2x. Take the derivative of that, know the rule. So the rule, well, for x, the derivative is 1, and for sine, the derivative is cosine. And the derivative inside 2x is just 2, so it has that hook on to begin with. Notice it's negative only because it was negative before. So the derivative of negative sine is negative cosine if you want. It just means the sign didn't change. It stays the same. And keep going forward. Number 3. G at x equals cosine squared. So I'm going to write that so you can understand that better. So that's one way. In trigonometry, the exponent is written in the middle of the function. But for calculus, it might be helpful to rewrite it this way so you can understand what's happening. Because if I'm going to take the derivative of this, it's probably more helpful to write it this way so you can actually see it. So this is going to be the power rule. So 2 times 1 in front will make it 2. And then rewrite this. And then when you subtract 1 to the exponent, it's now 1, and I don't need to put a 1 there. Then the derivative of cosine. So first of all, the derivative on the outside is that. Now this part here, and if you like, this is all to the exponent 1, if that makes it easier to understand. Now the hook inside. So the derivative of cosine is negative sine. And then again, the derivative of x squared plus 1 is 2x. And you kind of have to follow the hooks as they go along. Number 4. That's theta. So tangent 3 theta subtract theta squared. All right. What's the derivative here? So I need to know the rule for tangent is secant squared. And then the derivative of 3 theta is 3. The derivative of theta squared is 2 theta, and it's over. So can you remember and apply your rules? So as you're practicing, it's okay to have the rules in front of you. So press pause and keep practicing the rules until you have them memorized. F at x equals ln cotangent x. What's the rule here? So the first rule is ln. So the rule for ln is what you see goes in the denominator, and then the derivative of what you see goes here. So for cotangent, it's a negative rule, and it's negative cosecant cotangent. No, it's negative cosecant squared, sorry. I got to make sure I remember the rules too. And that's it. Number 6. Y equals cosecant 2x minus secant x squared. All right, this might be a little bit longer. I hope I have room. So y prime equals. So what's the rule for cosecant? And the rule is negative cosecant cotangent. So I'm going to write this out. So negative cosecant 2x cotangent 2x. That's the rule. So the derivative of cosecant is cosecant cotangent. It's negative. Whatever is there inside. And the hook for that, for 2x, is 2. How about the next part? I'm going to run out of room, so I'm going to go underneath. So I'm subtracting, and the derivative of secant is itself, secant, and tangent. And then the derivative, oops, it shouldn't be 2x. What is it? X squared and x squared. And then the derivative of x squared, the hook on is 2x. All right, number 7. F at y equals y squared subtract secant y over y cubed. This is the quotient rule. All right, what's the quotient rule? The bottom times the derivative of the top, which would be 2y. The derivative of secant is itself and tangent. Keep going, subtract the top. Just be a rule follower, just keep it going. Times the derivative of the bottom. And then you take the bottom and square it. Done. Number 7. I have a waste paper basket across the room, so whenever I'm done a piece of paper, I like take shots and then I keep track of my stats to know how many I put in the waste. So that one went in. Do you hear that sound? All right. I just did number 7. Did I not? Why am I doing number 7 again? How about number 8? Ignore that one. I was too concerned about my waste paper stats of how many times I could put a ball of paper into the waste paper basket. T cubed, and then it is tan. Now I'm going to write it this way because I think there's so many 3's involved. I want to make sure that you understand what's happening. So in trigonometry, the exponent is put in the middle, but for us for calculus, it's probably helpful to understand it up here in the top right corner so you apply the correct rule. So first of all, this is going to be the product rule. That's the first t cubed times the derivative of the second. This is the tough one. So we're going to go 3 times 1 in front, rewrite the entire base inside out, subtract 1 to the exponent, and then we have a hook. The derivative of tangent is secant squared. And then we have another hook. The derivative of t cubed is 3t squared. And so far we've done the first times the derivative of the second plus the second times the derivative of the first. Done. I know. So again, the first times the derivative of the second, which has 2 hooks involved, plus the second times the derivative of the first. 9. H at x equals sine. Pi is just a number, so pi x plus pi x squared. So pi is just a number like 4 or 5. What's the derivative here? So the rule is the derivative of sine is cosine. And then the hook of pi x is pi. So the derivative of 3x would be 3. Pi x would be pi. Plus 2 times pi is 2 pi. Subtract 1 to the exponent, and that's it. So this is not the product rule because pi is just a number, not a variable. Number 10. F of theta equals negative 2 theta divided by sine theta. This is going to be the quotient rule, where it's the bottom times the derivative of the top, subtract the top times the derivative of the bottom. The derivative of sine is cosine, and then square the bottom. Done. Number 11. So we're just applying the rules of derivatives with trigonometry involved. Number 11. So that could be the product rule, the quotient rule, the chain rule, implicit differentiation, all the different rules with logarithms, exponentials. Now we have trigonometry as a part of that. Number 11. Oh, I forgot y equals. So the derivative of cosecant, the rule is start with itself, and then it's negative, sorry. So it's negative cosecant cotangent. It's good to remind yourself that 1 over x is x to the negative 1. So the derivative of 1 over x is negative x to the negative 2. So negative 1 in front, and then subtract 1 to the exponent. So it's negative x to the negative 2. And then the second part, it might be helpful to recognize that is x to the 1/2. Oops. Instead of the square root of x. So 1/2 times 3. And then subtract 1 to the exponent. So it's 3/2 x to the negative half. 12. So again, I'm going to write this as cosine t subtract sine t to the exponent 1/2 instead of square root. The derivative of this, start with 1/2 in front. So 1/2 times 1 in front. This is the power rule. And then subtract 1 to the exponent. And then this becomes a chain rule where the hook or chain involved is the derivative of the base. So the derivative of cosine is negative sine. The derivative of sine is positive cosine, but there's a negative in front, so it makes them both negative. So it's negative sine t subtract cosine t. If this was ever multiple choice, you'd have to have at least the skill to recognize what's happening, that this is square root of cosine t subtract sine t. And the numerator would be this. So the negative exponent and the negative 1/2, that puts that in the denominator. So this would be a great multiple choice question. Or could you write this as a fraction and recognize the answer that's in front of you? Number 13. More derivative rules. So f at x equals, that's the only way to know the rules by memory, is by practicing them. There is no real shortcut to those kind of things. Either you put the work into it or you don't. So the derivative for the rule, so start with tangent. The rule for tangent is secant squared. So I go secant squared and then copy everything else. And then take the derivative of the inside. This is called the chain rule. So the derivative of the outside times the derivative of the inside. So ln, the rule is what you see is in the denominator, and the derivative of that is the numerator. And that's done. Number 14. So again, we're trying to put all the rules together. Power rule, product rule, quotient rule, implicit differentiation, logarithms, exponentials, and now trigonometry. And the best way to remember all the rules is by practicing them and putting the work in to remember them. It's not going to happen by accident. So the derivative, start with ln. So what you see, remember the absolute value doesn't change. The rule would still be. So there's no absolute value in the answer. So what you see is in the denominator. And then the derivative of that is in the numerator. So what's the derivative of this? So the rule for secant is itself with its friend, tangent. And then the derivative of 3x is 3. So there's an extra hook at the end. And that's what it looks like. Number 15. Oh, here's a good one. You could simplify this. Do you notice secant 3x and secant 3x divide out? So the end answer could be written like this. So on multiple choice, you'd likely see that. So have the ability to simplify if you have to. 15. Exponential. E to the exponent sine x times cosine x. So again, it's this ability to remember all the derivative rules and putting them together. So this is like the most important assignment so far in terms of derivative rules, because these are all the rules. And you can say, there's still some more. There's a few more. So the ones that are left we haven't done are inverse trigonometry, and that's coming up. But right now, this is all of them so far. What's the rule for e to whatever? And the answer is copy it. And then what's in the exponent, you take the derivative of and you multiply. So times the derivative of the exponent. This is the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. And there you go. So you could write that as sine squared x and cosine squared x. And you could write as one subtracting the other and so on. But that's good the way it looks. Number 16. Y equals e to the sine x times e to the cosine x. Well, if you're multiplying and the bases are the same, the first thing I'm going to do is write that as 1, exponential, by adding the exponents. Then when you take the derivative of e to whatever, you copy it, times the derivative of the exponent. So the derivative of sine x is cosine x, the derivative of cosine is negative sine x, and it's done. Number 17. F of x equals negative cosine 2x. And the question is, write an equation of a line tangent to that. So do you know how to write an equation of a tangent line? So I need x, y, and I need to know the slope. That's the tangent line. So in the question, it tells you the x coordinate is pi over 6. The y coordinate is negative 1/2. And to find the slope, I need to take the derivative. So the derivative of cosine is negative sine. So a negative and a negative will make it positive sine. 2x plus the hook, which is 2. Next, you're going to substitute in. So the x coordinate is pi over 6. Now, if this was free response, you could write the answer like this. The slope is 2 times sine. Now, 2 times pi over 6, you wouldn't even need to reduce it down, but that is pi over 3. That's the slope. And then x subtract pi over 6, subtract 1/2. So the x coordinate and the y coordinate, and that would be a great answer. But likely this is going to be a multiple choice question, which means you'd have to know how to simplify that. So the value of sine at pi over 3, what's the y coordinate there? So it's a 60-degree reference angle, and the y coordinate there is root 3 over 2. And so on a multiple choice, it's very likely that you would see the 2's divide out, and you would see this as the final answer to pick. So do you have the ability to keep going if you had to? Number 18. All right, I'm going to try again. You ready? Tell me, what do you think? I'm 1 for 1. Am I going to be 2 for 2? 2 for 2. I know. Wasting talents on calculus. I could join the waste paper basket tour. F of x equals tangent x squared subtract 1. And we're doing the same thing. Equation of a tangent line. So it's at x equals 1. I'm not given anything else. All right, so that means I need to plug 1 in for x to find the y value. So 1 squared take away 1. That's the value of tangent at 0. And the value of tangent at 0, y divided by x, is 0. And I need to take the derivative. So the rule for tangent is secant squared. And again, I'm going to plug in the x value to find the slope. So it's secant squared, 1 squared take away 1. So 1 squared take away 1 is 0. So in other words, what's the value of secant at 0 and square it? So for this one, again, understand this point here on the unit circle. Secant at 0, it's the x-coordinate and it's the reciprocal of the x-coordinate. That's cosine. So the reciprocal of 1 is 1, and 1 squared is 1. I know it takes practice. So the x-coordinate, the y-coordinate, the slope, put it together. So the slope is 1. Oops. The x-coordinate is 1, so it's x minus 1. And then I don't need to put 0 at the end. So you could definitely see the answer is just y equals x subtract 1 is your final answer. Oh, you know what I did wrong? I'm going to go back. What's the derivative? There's a hook here. So it's not just secant squared x, but there's a hook. The derivative of x squared subtract 1 is 2x. You probably got that, and I forgot. So for this, I'm going to plug 1 in for x. I'm forgetting 2 times 1 here. So if I do that, I need to go times 2 to this answer. So the slope really is 2, because I forgot the hook when I plug 1 in for x. So all that does is change this to 2. So this is 2x minus 2. Sorry about that. Number 18. At least I'm 2 for 2 with the waste paper basket. By the way, this was not 17. That was 18. This is not 18. This is 19. So let's try again. Y equals sine, 2 sine, negative x. And again, what's the equation of the tangent line? So x is pi over 4. Y would be 2 sine, and you plug in pi over 4 for x, and then simplify it. So on the unit circle, negative pi over 4 would be here. And that point is positive root 2 over 2 and negative root 2 over 2. On the unit circle, sine is the y value there. So it would be negative root 2 over 2, and then the 2's divide out. So the slope there is negative root 2. To find the slope, I need to take the derivative first. So the derivative of 2 sine negative x would be 2 cosine negative x. But the derivative of negative x is negative 1, which makes that a negative 2 cosine negative x. Then for the slope, plug in pi over 4. And we're at the same point. So what's the value of cosine at negative pi over 4? That's here. It's the x-coordinate, though, which is positive root 2 over 2. And again, the 2's divide out, and you get negative root 2. And then if you put it together, the slope is negative root 2. The x-coordinate was pi over 4, and the y-coordinate was negative root 2. And there it is put together. Perfect. I was just checking the answer key. Number 19. We did 19. Number 20. Use a calculator. I love using a calculator. All right. Write the equation for the lines tangent to and normal to this graph. I get to use a calculator, so it gets to do all the tough work. Okay. So I'm going to type that in. So first I need to know the y value. So to find the y value, just plug it in and type it in. So let me erase this. And away we go. So I'm going to go ln absolute value cosine. And now I'm going to plug in the numbers. So it's 0.821. Move the cursor, plus 2. And I got something. All right. Now I'm going to save that. So I'm going to highlight it and then go Control V. Oh, Control C. And now it's copied. All right. So I'm going to round it here. So it's 0.986. But I saved it in my calculator. The slope, how would I do that? I'm evaluating at what? So let's do it. I actually didn't need to save it in. I don't need that. So it's fine that I saved it, but I won't need it. So how do I take the derivative at a point? Press menu, calculus, derivative at a point. It is, x is our variable. The value is at 0.821. Okay. And then just type in what we just did, which is ln absolute value cosine x, move the cursor, plus 2. Double check, did I type it in correctly? Control enter, and I get negative 0.272. So type in negative 0.272. And then I'm going to put that all together. So the tangent line then would be y equals negative 0.272. That's the slope. The x coordinate, so it's x subtract 0.821. And then the y coordinate plus 0.986. So that would be the tangent that we're looking for. And then what would the normal look like? We're going to make this really simple. So the normal is just the reciprocal. So the reciprocal of that would just be 1 divided by. So just make it really simple. I'm not changing the sign of it. Or am I? I am. It's the opposite reciprocal. So make this positive. So instead of negative, it's positive. And just go 1 over that number. That's perfect. That means perpendicular. And then x subtract 0.821 plus 0.986. There's the tangent. And there's the normal. All right. Number 21. I just did 21. Nope, I didn't. 21. Find the domain, intercepts, extrema points, and da-da-da, and sketch it. So y equals sine x plus cosine x. And we're going to graph that from 0 to 2 pi. All right, we're not giving up on this. So first step is domain. There is no restrictions for sine or cosine, so it's all real numbers. In this case, the domain goes from 0 to 2 pi, I should actually say, because it tells you there's a restriction. So this isn't, it would normally be no restrictions, but it says 0 to 2 pi, so that's the domain. The intercepts, so to find the x-intercept, we make it equal to 0 and solve it. So I'm going to subtract cosine x and then realize at what angles are they equal to each other, but one's positive and one's negative. So that's a 45 degree. So that's over 4. And it's quadrant number 2 and quadrant number 4. So in these angles, sine and cosine are opposites of each other. So one's positive and one's negative here. So it's 3 pi over 4 and 7 pi over 4. For the y-intercept, we just plug in 0 for x. So y equals sine 0, plus cosine 0. So the value of sine at 0 is 0. The value of cosine at 0 is 1. So it's really 0 plus 1, which is 1. So there's your y-intercept. So we have that as your y-intercept. Here's your x-intercepts. That's all pre-calculus. How about like the maximums and minimums? So now we're going to take the derivative and find any extreme values. So the derivative of sine is cosine, and the derivative of cosine is negative sine. And again, we're going to make it equal to 0. There's no restrictions here. So I'm going to add sine x to the other side. At what angles are they equal to each other? And the answer to that is pi over 4 and 5 pi over 4. So that's quadrants 1 and 3. Cosine and sine are equal to each other at those angles. And then if I did a number line, I could understand if they're positive or if they're maximum or minimum. So the number line goes from 0 to 2 pi. And I'm going to put down pi over 4 and 5 pi over 4. And I want to have an understanding if it's positive or negative when I plug in here. So sine plus cosine. So first of all, sine is bigger than cosine to begin with, but then it changes. Oh, sorry. Say that again. So for the first derivative, yeah. So if I plug in a value between 0 and pi over 4. So if I plug in pi over 6, the y-coordinate is bigger than the x-coordinate. But anyways, it's going to give you a positive answer. If I plug in a number between pi over 4 and 5 pi over 4 into here, then we have to understand what's happening in terms of that, into the derivative. I'm sorry. Why did I go back to the top? So if I plug in pi over 6 here, the value of cosine of pi over 6 is bigger than sine pi over 6. But if I plug in pi over 3, which is in between here, or pi over 2, that would mean that this would give you a negative answer. I'm going to help you through it. And then if you plug in an angle in quadrant number 4 in here, the x and so on, the sign will change again, where it becomes positive, negative, and then positive. So this is a maximum, and this is a minimum. So we know we have a maximum at pi over 4. If I plug that in to here, you would get root 2 over 2 and root 2 over 2. So that's 2 root 2 over 2, and that just simplifies to root 2. The minimum is at 5 pi over 4, and that would be negative root 2 over 2 and negative root 2 over 2. So that simplifies to negative root 2. So there's our maximum, and there's our minimum. Now we're going to take the second derivative. So the second derivative here of this, the derivative of cosine is negative sine. The derivative of sine is cosine. And again, if I make them equal to 0, this is the same situation I just had for the intercepts. So where the intercepts are our point of inflections. So this situation here is exactly what I just solved here. So we have point of inflections at 3 pi over 4 and 7 pi over 4. And again, we could draw a number line to show that. For the second derivative, so if I plug in 3 pi over 4 here to see what the answer would be, it's a negative, and then it's a positive, and then it's a negative for the second. So it's concave down, concave up, concave down. So we already know that at 3 pi over 4, it's a intercept. And at 7 pi over 4, it's an intercept. So 3 pi over 4 and 7 pi over 4 is 0. So now I have everything I need. So now I'm going to graph this. So we're going to graph it to 2 pi. This is pi over 2, pi, 3 pi over 2. So what would this look like? So first of all, the max goes up to root 2, and the minimum goes down to negative root 2. So I have that on my axes. I know the intercepts are at 3 pi over 4. That's here. And another one at 7 pi over 4. That's here. Those are also my point of inflections. At pi over 4, it goes up to root 2. At 5 pi over 4, it goes down to negative root 2. And you can kind of see a pattern that's going to form here. And then complete it from there. Oh, and the y-intercept's at 1. So I'm only going to graph it from here to there. So first of all, it's concave down. And then it's concave up. So it's concave down, concave up, and then concave down. And there you go. And technically here, this should be a hole right here because it doesn't include 2 pi. So if you would graph it, this would be a hole there. And to make sure that's concave down, this is concave up, concave down. This one's not a hole because we are graphing from 0 to 2 pi. So this end's a hole and this end's solid. And that was hard work, right? To get through it. So it's okay to go back and go through the question again slowly to be able to understand each part of it. But if you followed what we just did, that's huge, right? That's a 5 on an AP exam if you can put all those pieces together. All right, on to number 22. Can I go 3 for 3? Here's the question. No, 2 for 3. Okay. I gotta forget about my failures and next time put it in the waste paper basket. All right, implicit. So cosine y subtract x equals x cubed plus 2. So I want to take the derivative implicitly. So the derivative of cosine is negative sine. The derivative of y is y prime, and the derivative of negative x is negative 1. And then the derivative of x cubed is 3x squared, and the derivative of 2 is 0. All right, I want to get y prime by itself. So honestly, the easiest way is to divide. So I'm going to divide by negative sine y subtract x. And then the next easiest thing is just to add 1 to it. And that's it. There it is. Number 23. See, that was a lot easier, right? 2xy equals tangent y squared. Take the derivative implicitly. 2x times y is called the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. And there it is. That's the product rule. The tangent, the rule for tangent is secant squared. And then the derivative of y squared is 2y. All right, so that's the hardest step right there. Now we're going to gather together the y prime. So I only have that. Oh, and what did I go? The derivative of 2y squared is 2y, and then what does it need here? A y prime. Man, that's a big mistake if I don't include that y prime. So we have 2x y prime. I'm going to subtract all of this. So they're all together over here. And I'm going to subtract 2y, so it's on the right side. So some heavy lifting algebra. So I want the y primes to be together. And then I'm going to factor out a y prime and be left with 2x subtract secant squared y squared 2y. And then the last step is to divide. Just double checking, making sure that my algebra is okay. And it is, but I know I can make mistakes too. So 2x subtract secant squared y squared 2y. And you can see where I almost made the mistake, right? By not including y prime for that hook at the end there. But this is the answer here. And we're done. All right, 24. Some limit questions. We want to see if it's indeterminate and whether I can apply L'Hopital's rule. So cosine x divided by x subtract pi over 2. So we're never going to write down 0 divided by 0. So we're going to separate this numerator and denominator. So pi over 2 is at the top of the unit circle. The x-coordinate there is 0. And then the denominator, obviously x subtract pi over 2. If you plug that in, you also get 0. This is indeterminate. So L'Hopital's rule, we're going to take the derivative of the numerator and then the derivative of the denominator. So the derivative of cosine is negative sine, and the derivative of the denominator, the derivative of x is 1, the derivative of negative pi over 2 is 0. So there it is. And then we're going to substitute in. So the precise answer is negative sine pi over 2. That would be a great answer if it was free response. But if it was multiple choice, you'd have to know what's the y-coordinate at the top of the circle. That's positive 1. So if I plug in positive 1, there's a negative in front. So the whole answer is negative 1. That's the limit for number 24. Number 25. For number 25, we have the limit as x approaches 0 of sine 2x over sine negative 5x. All right, so is this indeterminate? So at 0, the y-coordinate is 0. So this is 0 over 0. So I have to show that. So the numerator, the answer is 0. This is indeterminate. The denominator, it's 0. And then because it's indeterminate, I can then apply L'Hopital's rule. So L'Hopital's rule is the derivative of the top. So the derivative of sine is cosine. And don't forget the hook 2. The derivative of sine is cosine. Don't forget the hook negative 5. Now what happens when I plug in 0? I get the value of cosine at 0. Well, the value of cosine at 0, it's the x-coordinate there. This is the point. So it's the x-coordinate, which is positive 1. So this is not indeterminate. This is 1 times 2. This is 1 times negative 5, and you get your answer. 26. In number 26, you have the limit as x approaches 0 of sine 3x over x. This is indeterminate, so we're going to show that separately. So sine 3x. So if you plug in 0, the value of sine at 0 is 0. And then the denominator, it's 0. So L'Hopital's rule, the derivative of the numerator, so that's that's positive cosine 3x times 3 and 1. Now when you plug in 0, the value of cosine at 0 is 1 times 3 divided by 1, and you evaluate the limit. 27. The limit as t approaches 0 of 2t secant t. So the value of secant is the reciprocal, right, of cosine. So again, at 0, the x-coordinate's 1. So the reciprocal of 1 is 1. So this is not indeterminate at all. You just plug it in, and you get 2 times 0 times 1, which is 0, and it's over. 28. It's not going to be L'Hopital's rule unless there's a ratio, a fraction. 28. Without a calculator, convert to radians. Well, that's nice to have an easy question. So 300 degrees is the same as what in radians? So it's times pi over 180. That would be the same as, do you know? 5 pi over 3. B, negative 5 pi over 2. That would be the same as multiplied by 180 over pi. So the pi's divide out. That's 90 times 5, or 9 times 5, right? So it's negative 450. 29. Some right triangle trigonometry. So some pre-cal practice with trig. We have a triangle, a right triangle, 5 and 3, and asked to find sine, cosine, and tangent of that triangle. So in order to do that, I need to use Pythagorean Theorem. That's a squared plus b squared. That's 25 plus 9, right? So that's the square root of 34. And then we don't have to rationalize anything. So it's opposite over hypotenuse. It's adjacent over hypotenuse. And then it's opposite over adjacent. Done. And don't worry about the root 34 in the denominator. 30. All right, I'm 2 for 3. You ready? 2 for 3. Oh my goodness, 2 for 4. I can't lie on the video. Where are we at? 30. 50% from the arc. Here we go. So, all right, so we have a point. X is -2, y is -1. The radius is the square root of x squared plus y squared. So that would be the square root of 5. And then cosine is the x over the radius. Sine is the y over the radius. And tangent is y over x. Done. And a negative divided by a negative, positive a half. 31. So this tells you the angle. So the angle is 8 pi over 3. And then can you find sine, cosine, and tangent of that angle? So that's the unit circle question. Over 3, that is a 60 degree. The order would be 1/2 and root 3 over 2. So I already know the y coordinate is root 3 over 2. The x coordinate is 1/2. And when I go y over x, it's root 3. What I don't know is the quadrant it's in. So let's do that together, because that tells me if it's positive or negative. So we have 1 pi over 3, 2 pi over 3, 4 over 3, 5 over 3, skip 6, 7 over 3, and 8 over 3. Winner. So in quadrant number 2, sine is positive, cosine is negative, and tangent's negative, because you're dividing y divided by x. Done. That's number 31. 32. Turn the page. In 32, you have a triangle. The angle on one is pi over 6. And you're asked to solve this. So this is actually a special right triangle. That's 30 degrees. This is 60. And that's 90. It's a 30, 60, 90. The ratio of the sides for that is 1, 2, and it's 1, 2, and root 3. So across from, there's a relationship here. The side opposite of 30 degrees, you double it to find the hypotenuse for the special right triangle. So x is just 20. That's it. Number 33. And this side would actually be 10 root 3. 33, but you didn't need to know it. All right, and then I soon get to use a calculator, which is fun. So 33, use a calculator. Tangent squared equals sine 2x plus 3 from 0 to pi. All right, we're going to practice. How do you type that in your calculator to solve it? Here we go. You ready? Press pause if you don't have it. Now if you have your calculator, press play, and we're going to do it together. So we're going to go menu algebra, and then solve. And then we're going to type it in. So I'm going to type in, and I'm going to use parentheses, and then tangent, x, and then square it. That's the best way. Just like that. Okay? Equals sine, and it's 2x. Move the cursor, plus 3. We're almost there, comma x. And then at the end, we have to put a restriction. So we're going to go control equals, find that vertical line, and then we're going to put in the restriction. And the restriction goes from 0 to pi. So I'm going to put in 0. I'm going to go control equals, try that again, control equals, and it's the less than arrows we're going to use. So it's less than or equal to, right, for 0. X, and then again control equals, now this one's just less than, and it's pi. Man, we're there. Ready? Control Enter. And there's the answer. So it's 1.097 and 2.179. Perfect. That's my answer key got. And we're done. So just take your time and it's there. I like it when the calculator does the work. I know you do too. And you have your two answers. 34. This is without a calculator. So negative 3/4 cosine 3x minus pi. I kind of put an extra parentheses there, but it's the same thing. And let's go. Amplitude. It's the absolute value of 3/4. That'd be 3/4. Period. So if I look here, it'd be 2 pi divided by 3. The phase shift, believe it or not, you take, and it's the inverse of that divided by what's in front. So it's positive pi over 3. Positive pi over 3. That's how you find the phase shift. Done. Didn't say to graph it. 35, we are graphing. So do a sketch for 35. I'm just going to get right to it. So I'm going to go 1, 2, 3, 4. The one thing I need to know is the period, because that helps me. So the period would be just 2 pi. Because there's nothing in front of x that would change the period. It's just 1x. The phase shift is positive pi over 2. That's helpful. So right here, at positive pi over 2, we're going to start. Oh, and sine starts in the middle. All right. Sorry. And then our amplitude is 1/2. So it goes there to there. So it's 1/2 to negative 1/2. And then recognize that this is where we're starting. And negative sign starts in the middle and goes down. And then you just follow the pattern. Done. $36. All right, find the discontinuities. What does that mean? That's where the asymptotes are. Oops, that's cosecant 4x. There's no domain restriction, so understand that for cosecant, it starts with an asymptote. And then this is what it would be. It would be 0, and then it would be pi, and then it would be 2 pi, and then so on. That's the pattern for where the asymptotes are for cosecant. But I'm going to divide it by 4, that these are where the asymptotes are. So it's 0, 1 over 4, 2 over 4. It would be 3 over 4. So it's every multiple of pi over 4 is the asymptotes. 37. Write an equation of this graph that you see below. We're almost there. You know that, right? 39 is coming. So what's an equation of that? So that's a tangent. And what things do I notice? Well, the point of inflection's been up 1. So there's a vertical shift of positive 1. So that's what D is. Tangent starts with a point of inflection. So there's no phase shift unless I want it. So I don't want a phase shift, so I'm not going to put one in. It goes up to the right and down to the left, so it's positive. I just need to know the period. And so the period for this one, actually, from left to right, is 2 pi. I know it's a little confusing. But from 0 to pi is not a full cycle. So from negative pi to positive pi, that distance is 2 pi. That means the period has been doubled. So what does that mean for my function for 37? So some things I said. Oh, and also a couple other things. Do you see the from here to here? So normally, the next point for tangent would have been at 2. So it would have been up 1 and to the right 1. But this is up 2 and to the right 1. So it's been stretched by 2. So that means A in front would be 2 because it's been stretched by 2. I said there's a period change. It's been doubled. So how do I show that? Is divide by 2. That means the period has been doubled. And there's a vertical shift. It's been shifted up 1. So 2 times tangent x divided by 2 plus 1, that is this graph. So there's a stretch of 2. It's been shifted up 1, and the period has been doubled. And all of that information is right there. 38. Find the equation of the line tangent to that point. So if I want to find the equation of a tangent line, I need to know what x equals, negative pi over 4. I need to know what y equals, negative 2. And I need to know the slope, which is the derivative of what I'm looking at. So the derivative of 2 tangent x would be 2 secant squared x. That's the derivative. And then you plug in, negative pi over 4. So it's not negative pi over 4 squared. It's the whole thing is squared on the outside. So at negative pi over 4, I need to know where that is on the unit circle. It's right here. And the point on the unit circle, it's the x coordinate. So it's root 2 over 2, root 2 over 2. So the x coordinate is positive and the y is negative. It's the reciprocal there, which is 2 over root 2. So, and then that's squared, 2 over root 2. So if I simplify it, that's 4 times 2, which is 8, and root 2 squared, which is 2. So altogether, that slope would be 4. And now I'm done. So the numbers are, the slope is 4, x plus pi over 4, and then subtract 2. And there's the HK form, the equation of a tangent line. All right, what you've been waiting for. Our last question, number 39. In number 39, we're going to revisit problem 7 on page 56. That was 100 years ago. And then suppose the angle theta is formed by the ladder in the ground, and that's, I think it's phi. I'm not sure what's with that when you put a line through it. The angle formed by the ladder and so on. So I'm going to draw the picture. So that's a Greek letter. It doesn't really matter if you know the name of it, honestly, because I forgot. So if you put a line down that's a Greek letter. I forgot. You can probably tell me by email what it is. That's theta. I know that one. And that we have A and we have B, just like that. And it says the ladder is 10 feet long. Well, that's simple. And it says the base of the ladder is being pulled away. That'd be B. So dB by dt, the answer is 1.5. And it's positive because it's getting bigger. At the instant, the base of the ladder is 6 feet from the house. So that means B is equal to 6. And if that's true, if 6, that means A must be 8, because 8 squared plus 6 squared equals 10 squared. It's a Pythagorean triplet. And these are the values I have. So I'm going to start with this. A squared plus B squared equals C squared. Oh, I'm finding the rate of change of the angle. So why will I not do that? So if I'm finding the rate of change of the angle, this is not going to help me because that has to do with the sides. So the first angle is theta. So if I look at theta and look at what I have, if I'm using B, it would be cosine. So I'm going to write down cosine theta is equal to, now B is changing over time, so I can't put 6 in yet. So it's B over 10. 10 doesn't change. And then I take the derivative of that with respect to time. So the derivative of this with respect to time, the derivative of cosine is negative sine theta. And then it needs a d theta by dt. And then the derivative of b over 10 is just 1 over 10. So it's like 1 over 10 times b. The derivative would just be 1 over 10. And then, do I know that angle that I'm looking for? Oh, and I need a dB by dt. Sorry. Also on this side. So what information do I know and what do I not know in terms of what's happening? So I know that B is 6 and dB by dt is 3 over 2 or 1/2. All right. So what's the value of sine theta with this triangle? So sine is opposite over hypotenuse. So that would be 8 over 10, and it's negative. I'm solving for this. And then the derivative of b with respect to time is already given as 1.5 or 3 over 2. And then I want to get this by itself. So this is 3 over 20. And then instead of dividing, I'm going to go times the reciprocal. And then that angle over time is getting smaller as b is going by. That's why it's negative. And I get 10 goes into 20 twice. So I get negative 3 over 16. And because it's in radians, is that what it says? The angle's in radians? But that's the answer. And it is in radians per second, if you like. So that would be the rate the angle is changing. So it's getting smaller. That makes sense. So as b is being pulled out, this angle gets smaller as b it gets pulled out. Now, how about the other one with respect to time? So if it's this one, now it's going to be sine. So it's I don't know what I want to call that. Phi, something like that. And opposite b, that's 6 over hypotenuse, which is 10. And now I'm going to take the derivative of that. So the derivative of sine is cosine, but it needs a hook of d phi over the respect to time. Oh, and I can't put 6 in right away. So this is b over 10. And the derivative of b over 10 is 1/10 again, but it needs the hook db by dt with respect to time. The value of cosine theta in this triangle, not cosine phi, in this triangle would be 8 over 10. And again, dB by dt is 3 over 2. So to get this by itself, I would just divide or times the reciprocal. So it's 3 over 20 times the reciprocal. And then if I reduced it down again, I get the same answer, right? 3 over 16. But it's positive 3 over 16 radian per second. And there you go. Even though it didn't say specifically it was in radians, definitely said about seconds. And there's your answer. So you found how the angle is changing per second, both here and here. So that was a tier 1 question for sure again, right? There's a couple toughies in there, but that's okay. We did them together, and we finished our assignment. So Mr. G Math over and out. I'm so proud of you for doing your work, and until next time.